Welcome to spiral review number 1. The point of doing the spiral reviews is to look at the things that we've learned this year and just really solidify it in our minds. So I want to go ahead and get started. One of the first things we learned this year was solving equations. So one of the ways I help you guys remember how to solve equations is by using this mnemonic device: set up, clean up, round up, wrap up, check up. So when you set up, you want to set up your problem in your headspace. Number one, believe that you can do it. I know that sounds silly, but it's really important. You have to believe that you can do it. Otherwise, you're just going to give up and you're not going to learn anything. So when you also set up your problem, you're going to be building your balance. So think of your equation as a balance, and everything you do on the left has to be done on the right if you're doing something to the left. Now, when you're cleaning up, sometimes you have to clean up on the left and the right before you undo things. So think about it this way: clean up your left and your right space, get all that cleaning up done, simplify as much as you possibly can. If you have variables on both sides, you're going to need to round them up on both, from both sides onto one side. And then you start to do opposites. That's why the balance is especially important. You want to wrap up by doing the opposite of the constant, opposite coefficient. And then you want to plug it back in and check up. Know that you can plug in and retrace your steps there. So set up your problem in headspace, clean up your left and your right space, round up your variables in one place, wrap up, know that opposites erase, and then check up, plug in and retrace. So I'm going to give an example for you, and then you're going to do one on your own. So when we set up the problem, we're going to go ahead and build our balance right here. And then I'm going to go ahead and do what we call our waitress, right, where we have 0.3 times W and then 0.3 times 10. So 0.3 times W looks like this, just 0.3 W. And 0.3 times 10 moves the decimal to the right, so it's just the number 3. And that's going to equal 1.8 W. Okay. Oh, my lights in my room just turned off. Okay, so moving along here, we've set it up. We've cleaned up the most that we can. So if we have variables and constants, that's going to be the best we can do. So now we've got variables on both sides. I've got 0.3 W here and 1.8 W over there. We typically move the smaller amount, right? So take away that 3/10 of a W. If it helps you to imagine it, imagine you've got like 3/10 of a whale or something like that. And you can kind of have that concrete example in your mind. So if I have 1.8 W minus 0.3 W, you can use calculator if you need to. That's going to be 1.5 W. And then I'm going to divide away, okay? Because now we're in the wrap-up stage, and we got all of our variables to the right side, and there's no constant to undo, so we just go right to undoing that coefficient. So 1.5 times W, let's divide that away, canceling it out. So now W is all alone, and 3 divided by 1.5 is 2. So W equals 2. And I could plug that back in and solve to make sure that the left side equals the right side. So now build your balance, get your variables on the same side, and then undo any constants and then coefficients on that one. Next up for transformations, okay, we want to do a reflection in this one across the y-axis, and the axes are labeled. This is our y-axis, remember, always going up and down. And then we want to translate it with the vector notation, which is a super fancy way of just giving us the ways that we go left, right, up, or down. So if I'm going to take this 2 steps at a time. So my first step is to reflect it across the y-axis. So you could think of it 2 different ways. You could imagine it as a mirror and say, okay, well, if my little A man is standing 1 step away from that mirror, he's going to stand the opposite direction of the mirror. If C man is 3 steps away from the right, we're going to go 3 steps to the left. So I'm going to make sure I label these: A prime, C prime, B prime. B is also 3 steps away from our mirror, so we're going to go 3 steps the other direction. And I could go ahead and make those A prime, B prime, C prime, but that was only one move. Okay, we want to move it again. We're not quite done yet. You could have also just kept your Y, because you didn't change how far up and down you went, you just changed how far left and right you went. So if you go ahead and say, okay, if I went over 1 up 1, I went -1 up 1 for the other one. So you could do it with coordinates, or you could do it visually. All right, so again, back to our vector rotation, we've got x plus 4, y minus 6. So our x is always our left-right movement. So if we add 4 to that x, think of that as a number line. If we add 4 to that number line, we're going to go to the right. So every point I have, I can scoot to the right, but then I also see that I need to go down 6. So my Y tells me up and down movement. And so I'm going to go down 6 since I'm taking 6 away. Again, think of that as a number line. We're going down 6. So I'm going to go to the right 4 and down 6 for each point. So we'll start with A. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So there's my final A prime. Let's do our B next. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. There's B prime. And last one, 1, 2, 3, 4 to the right. 1, 2, 3, 4, 5, 6 down. Here's my C prime. And then I can just connect those dots. That makes it a little bit easier to do those points. Oh, I feel like I made a mistake here. 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6. Here's my new C prime. It's like, that doesn't look right to me. Okay, so I'm gonna go ahead and color that new shape in and then give my new points. So A was at point 3, 1, 2, 3, 4, 5, 3, -5, and make sure that you do it on the proper letter. So when I'm doing my B, I really need to pay attention to this corner, not one of the others. B prime is over 1 and down 5 as well. And then C prime over 1, down 2. Got to be careful. Even I messed up on that one a little bit. Okay, so now on this one, it says reflect across the x-axis. So now my mirror isn't this way, it's this way. So you're going to be having your y number is going to change. And then you're going to go, if you add 5, you're going to the right. If you add 3, you're going to be going up. So make sure you get those coordinates correct for that one. All right, for my next one, I'm trying to get my camera be not so fuzzy here. I want you to list the perfect squares of all the numbers 1 through 20. So 1 squared equals 1, 2 squared equals 4, 3 squared equals 9. Because when you square something, visually what you're doing is you're taking that number and you're imagining, like, so let's say 5 squared. 5 rows of 5 squares, so 5 times 5 is a square block of 25. So I can find 5 squared right here, that's 25, okay? 9 squared right here, I'm going to just jump around, is 81. 13 squared is 169. 14 squared is, where's 14? Here it is, 196. So really close to 13 squared. Okay, but you just switch the 6 and the 9 there. So the lower one makes sense, would go with a 13 instead of the 14. So go through and finish those. But what I want you to do is when you're done, I want you to see that our numbers can be plotted. These numbers can be plotted in another way on a number line. So if I wrote out a normal number line, okay, with all the integers, it looks like -4 to 24 on this particular number line, I could also say the square root of 169 is 13. So 13 has another name. It's got a nickname. So 13 is also the square root of 169. So what I want you to do is rename at least 5 of those numbers on this number line and put in the name of the square root. So 13 has a nickname. It's the square root of 169 because 13 squared is plain old 169. So you got to go to your number line and then you go to the number 13. And I'm going to mark the square root of 169. And I know it gets a little bit crowded, so I gave a couple small examples, but put at least 5 more on there compared to what I already have there. Okay, so fill in all these blanks and then keep going. And then tell me, do you have a nickname? If you do, what is it? I know some of you know my nickname. So if you know my nickname, bonus points. I'm not telling you now. Okay. So on the back side, flip it over and it says, write the equations of the lines in slope-intercept form. Remember, I talk about this like our treasure map, slope-intercept form. If you know your slope and you know your intercept, then you can write the slope-intercept form. And the main point of doing all these kinds of problems is they want you to be able to represent pairs of points, coordinate pairs as points on a graph. We could graph it with a line. We could write it as an equation. We can go back and forth between all these different ways of representing this information. And it's just the whole idea is we're comparing one set of data to another set of data and how they relate to each other consistently. So I will do the first example, and we've done this before in class, but it's pretty easy. Once you know what to do, it goes pretty fast. So I always write it like this with those boxes there. Here's my slope, there's my intercept. Remember, I've given you that hint over here. And so we always start with the end in mind. It's like a sneaky pirate, right? And he's trying to trick us by putting the starting point at the end. The starting point is on our y-intercept, our y-axis, and we're right down here at -3. Okay, again, just think of this as a number line. And if this is 0, we go down 1, 2, 3. So -3. And then from there, we build with our slope. So we are going to, this is always hard for you guys, is remembering you have to start with a left dot. Okay, you guys might be tempted to go up to the left, but we want to start with the left and move to the right. So pick a dot on the left side and then move to the right. And remember, left dot, elevator, run. So left dot, go down 3 over 1, down 3 over 1. So it's a -3 over 1, which is just -3. But I want you to see the elevator and the run right there, okay? So y equals -3x minus 3 would be the simplest way of writing that equation. So take what you know from that example and do it yourself now with this one. Again, start with that ending point and then build with your elevator run. All right, next up is functions, okay? Again, talking about the relationships between two pieces of information, inputs and outputs, x's and y's, domains and ranges. Okay, if I plugged in this value or this number for x, what would I get? What's my result? What's the output? What would I get for y? So all I have to do is say, okay, well, -2, with x is -2, -2 times -2, remember, buddy system, 2 negatives buddy up and cancel out and make a positive. So that's 4. 4 plus 3 is 7. Okay, I got my +3 from right here. All right, then let's plug in -1. -2 times -1 is +2. And then add 3 to +2 and I get 5. 0, -2 times 0 is 0. And I add 3 and I get 3. -2 times 1 is -2, plus 3 is 1. And -2 times 2 is -4, plus 3 is -1. Okay. And if it's a nice boring linear equation, you'll see a predictable output here, okay? There's a pattern here. Now, sometimes they jump around with their inputs and they don't put them in a nice, neat order, and that means your outputs might jump around as well. On this one, I didn't do that too, though. I just kept them -2, -1, 0, 1, 2, so you can see that connection there. All right, last up, application. Write and solve an equation to find the value of x. So I'm going to do one, and then I want you to do one as well, okay? So we've done something like this multiple times in class, and it's to help you understand you can write an equation that will help you solve for x. You have to know how things relate to each other. Sometimes you'll talk about things will add up to a certain amount, or things will be equal, or something might be double something else. And if you understand what that means, you can say, oh, well, if something's double, then this is 2 times that. And you can set up an equation and solve. So right here, I know that no matter how wide or skinny I make an x, that my angles are vertical angles, and that means that they're equal, okay? They're mirror reflections of each other, how wide they are. So I can use that information to write an equation. 2 times x plus 3 equals 4 times x minus 2. And now I just have to solve for x. So I'm going to follow the steps that I do when I solve equations. I'm going to believe that I can do that, and I'm going to set up with my building of my balance. I'm going to clean up on the left and the right, which means I've got to do my waitress. 2 times x and 2 times 3. 2 times x is 2x, and 2 times 3 is 6, positive 6. That's important because it looks like a +6. 4 times x is 4x, and 4 times -2 is -8. Looks like -8, right? It is -8. It's the same thing. Okay, so now I've got to round up. I've got x's on the left and the right. I can't start undoing those things until I round them up on one side or the other. And we typically move the smaller one, because if we move the bigger one, we're going to be dealing with negative x's, and we just want to avoid that if we can. So I'm going to take away those I'm going to take away those 2 x's, get those out of there. Okay, I'm left with a +6 equals 2x minus 8, because 4x minus 2x, if you think about, you've got 4 x-men, you take 2 x-men away, you've got 2 x-men left, okay? So now I build my balance, I cleaned up the left and the right, I rounded up my variables on one side, and now I need to go ahead and do opposite. Okay, I'm wrapping up opposite constant, opposite coefficient. Opposite that plain boring number. So adding 8 is the opposite of subtracting 8, right? But I've got to do it on both sides. I want you to show all your steps. You're writing this down as I'm working. 14 equals 2x, so I'm going to divide, if it's beside it, divide it, right? I'm going to divide that 2 away, and x equals whatever 14 divided by 2 is, and that's 7. Okay,